The idea of growing different aquatic species together to improve crops and benefit the environment is an age-old concept, but new to modern aquaculture in North America and Europe.
I think at the present time, being the only project that has the three species together, I think we are the cutting edge of modeling what really modern integrated aquaculture is.
If we can demonstrate that we can grow a safe, economically feasible product, I could see it as being part of the way we do business.
An Aquanet research project at the University of New Brunswick, co-led by Dr. Terry Chopin and Dr. Sean Robinson, and a team of scientists at the university and the St. Andrews Biological Station, combines finfish, shellfish, and seaweed to form an integrated, environmentally balanced system. It also involves aquaculture companies to explore how they can incorporate this new concept into their businesses, and the Canadian Food Inspection Agency to monitor health and safety aspects. This innovative pilot project combines laboratory and field research to safely culture shellfish and kelp in close proximity to salmon farms. Highly sophisticated feeding systems for cultured salmon have helped to optimize feed consumption and reduce wasting pellets that fall to the bottom and dissolve. Fish also produce discharges rich in the nutrients nitrogen and phosphorus. Tidal currents and other factors determine how quickly these nutrients are dispersed in the surrounding water. The approach in integrated aquaculture, however, is not dilution, but conversion.
Integrated aquaculture, it's when you combine several species. What is important is to combine what is called fed aquaculture, which is a salmon that you feed with pellets, with extractive aquaculture. So the mussel will extract the organic matter, the particles that they will absorb, and the other part, which is the inorganic extractive, where you have the seaweeds that are absorbing the nutrients, especially nitrogen and phosphorus. So when you combine all three together, you balance the system.
In the Bay of Fundy, seaweed and mussels are cultured at 3 different integrated research sites to examine the differences in growth patterns, environmental conditions, feed conversion, toxicity levels, and explore the economics of an integrated system. For Dr. Scott McKinley, Aquanet's Executive Scientific Director, this innovative project demonstrates exactly what Aquanet is all about.
Aquanet is what we call a network of centers of excellence in aquaculture. Our mission is to help foster a sustainable aquaculture sector in Canada through research and education. Our long-term goal, our legacy, will be essentially the eventual harmonization and the integration of both the culture fish and the captive fish into one sustainable aquaculture sector, speaking for academia, First Nations, NGOs, and the industry. This integrated aquaculture project speaks to a creative, innovative approach to help Canada sustain aquaculture.
Salmon farmers tend to see mussels as a nuisance. They settle on and foul the nets of salmon pens and have to be removed and discarded. Not so in this project. Because mussels feed on the dispersed particles in the water, they play an important role in the cleaning, or so-called bioremediation, of the nutrient-rich water near salmon farms. So why not turn a nuisance into an opportunity? Studying the growth patterns and conditions of these mussels and the ecological balance of the system is the focus for Dr. Sean Robinson at the St. Andrews Biological Station and graduate student Tara Lynn Lander. So far, the results have been very encouraging.
They've about doubled their weight in that month. The mussels do very well when they grow next to the salmon farm. Now that's not a big surprise. The mussels were growing almost twice as fast at the salmon sites than away from salmon sites.
The researchers have been working in conjunction with the Canadian Food Inspection Agency to ensure that the mussels meet Canadian food safety standards.
We've been checking things like any toxins that are produced by the natural phytoplankton in the water, any drug residuals that might be in there, therapeutants. We've been looking for heavy metals in the water, any signs of the other pollutants that would come in there, PCBs, that sort of thing. The bottom line is that we don't really seem to see any problems. So there'll be quality control, there'll be complete food safety tracking going on through the whole time. All in all, the food safety issue is a good news story.
On a return visit, Dr. Sean Robinson monitors the growth of the mussels.
So basically there's been about 3 months worth of growth so far on this. I think they're growing incredibly well.
A blind taste test confirmed that the mussels grown close to salmon sites are just as tasty as those grown at regular sites and help meet the growing demand for shellfish products.
We've had all sorts of interest, and there's a lot of people sort of peeking over our shoulders waiting to see what happens. And I think what we'll see is probably a bit of a gold rush for people to try and adapt, because it's a very low-cost add-on to your system. This is an alternative. Rather than it costing them money, they can actually make money on the seed.
The research has convinced Patrick Fitzgerald, supervisor for marine operations for Heritage Salmon in New Brunswick, to explore this idea further.
We initially became involved, more or less out of curiosity, working on salmon farms. We noticed that the mussels do grow fast, so we knew they were onto something. As time went on, became involved in some other issues, we see it as a possibility of bioremediation of salmonid finfish sites. What we have to make sure is that what's driving this industry are the finfish. As we move on, if we have a marketable product and we can demonstrate that we can do the polyculture, I think the industry would readily embrace it.
Besides salmon and mussels, seaweed is the third component of this integrated aquaculture system and the focus of Dr. Terry Chopin's research. One of the challenges and key accomplishments of this project has been to successfully rear the seaweed species Laminaria from seed to harvest and to refine culture techniques. When the young kelp are approximately ½ millimeter long, it's time to transfer them from the lab to the sea.
The seaweeds are growing 46% faster when they are closer to an aquaculture site than when they are away, and the mussels are more than doubling their weight. So altogether it shows that the two other species, the seaweed and the mussels, are taking advantage of the food that is there anyway. So as a matter of fact, if we can use more of it for all three species, it's a win-win situation for everybody.
In early July, the seaweed is harvested for analysis.
I think we have roughly ½ a ton of kelp here, and that was by harvesting only 3 ropes. So it's a pretty good production this year.
Raul Ugarte is a research scientist for Acadian Sea Plants, which harvests and processes marine algae, and is also one of the companies participating in the project.
We are always looking for alternative species like Laminaria, which is the seaweed that we just harvest today in the, along the ropes in the salmon cages. And those seaweeds are used for, at the present time, for animal feed or fertilizers. There are some potential uses for some of these alternative species, for nutraceutical, for the beauty industry, pharmaceutical. So there is a potential there that needs to be explored. It's a very small market yet, but has a good potential. One challenge is to expand this cultivation to a much bigger scale. So the potential is there.
The next step is to measure and quantify conversion ratios and develop a model for a balanced system.
So far we have done it at experimental level. We were interested in how do we grow mussels, how do we grow seaweeds. Second phase will be to scale up and then to develop all the economic model and the environmental model. And again, as I've said many times, don't put all your salmon eggs in the same basket. So diversify so that you can always gain something on one of the crop.
Before salmon farmers can become integrated aquaculturists, the rules governing aquacultural operations have to be changed to allow the culture of shellfish and aquatic plants in close proximity to salmon farms. This research is providing the scientific evidence to support this change. Providing seed funding has been important in this early stage.
What has been very important is Aquanet funding has allowed us to leverage of other source of money. Altogether, you have 31 people in the project and 9 graduate students, so it's quite a team.
For Tara Lynn Lander, graduate student at the University of New Brunswick, involvement in this project has provided exciting education and training opportunities.
This kind of science is brand new, and there are a lot of industries beginning to come interested in it, and it might open up some new doors career-wise with a new science coming on board. The Aquanet stipend has been increasingly important for living expenses as well as to carry out the research. Aquanet has done a great job in providing students opportunities to meet other people as well as industry.
After 3 years, researchers are finding that an old concept really is a new approach to modern aquaculture.
I think we are at the cutting edge of modeling what really modern integrated aquaculture is.
What I'd like to see happen out of this project would be to provide a new vision for people to look at the way we produce food in the marine environment.